Good day. Today we are going to have our lesson on exploring the regression analysis. This is the third lesson for the topic on correlation. By the end of this topic, we'll be able to identify the independent and dependent variables, calculate and interpret the slope and y-intercept, and predict the value of the dependent variable. Let's start by asking, how do we test the significance of R? Or we ask, if there is a relationship that exists, how do we know that the relationship is significant or not? We need to compute for our test statistic, and here's the formula in computing the test statistic. R refers to the correlation coefficient, N is a sample size, and the degree of freedom is computed by subtracting 2 from the sample size. In this lesson, we only have 4 steps in testing the significance of the correlation. First, we state the null and the alternative. Second, we compute for our test statistic. Third, we compare our test statistic with the critical value. And step 4, we make the decision and conclusion. Remember that for this topic, we'll be using the t-table, and the degree of freedom is computed as n minus 2. Again, the degree of freedom is n minus 2. Let's start with the first problem on family income and savings. A researcher investigated the relationship between family income and savings. Using the data from 15 families, the computed R between income and savings was found to be 0.76. Is the computed R significant at 0.05 level of significance? Can we conclude that the relationship really exists? So let's start by testing the significance of R. Now, step 1 is compute the null and the alternative hypothesis. Not compute, state, I mean. For the null hypothesis, we say that there is no significant relationship, or we say that R is equal to 0. So we state our null hypothesis. There is no significant relationship between family income and savings. Or we say that our correlation coefficient is equal to 0. For the alternative hypothesis, we say there is a significant relationship between family income and savings. Now let's compute for the value of t. Based on the problem, our sample size is 15 and our R is 0.76. We substitute these values to our formula, that is 0.76 multiplied by the square root of 15 minus 2, all divided by 1 minus 0.76 squared. Our t value is 4.22. Let's go to step number 3. In step number 3, we need to find the critical value or the tabular value. The degree of freedom is 15 minus 2, that's 13. And using our t-table for two-tailed, our t value is 2.16. If you check, our computed t is 4.22, and it's greater than the critical value of 2.16. If you'll draw your normal curve, 4.22 is found in the rejection region. Thus, we reject the null hypothesis. In step 4, we say, we reject the null hypothesis. Then you state the alternative. Thus, there is a significant relationship between family income and savings. That's the end for our first problem.